So going back again to this display, well, how is data written? Well, we have all these segments. We have, let's see what's going on here. So this is how, wait a minute. Okay, sorry. So one segment corresponds to 1 pixel, which is, and a pixel is on its own 4 bits. So 4 bits of 1 pixel indicate the grayscale level. I forgot about it, sorry. So it's not 1 bit per pixel, right? It's 4 bits per pixel, and you can indicate the pixel glow. So now you have 4 bits for a first pixel and 4 bits for another pixel. And so you have 480 possible pixels on the display resolution, but the actual OLED display has a subset of that in the middle, and a column then is using, you have 120 columns, so that means that you have 4 pixels per column. In other words, you have 4 segments per column. That's sort of how you can think of it. So that's why we see here 0, 0, and 0, 0. That indicates the column. And in the end, you have something like, or is that true? I think so. Right. Wait a minute. I have to think about it. No, because I was wrong. So we have 4 bits per pixel. And so 2 pixels are 8 bits. And we have 120 columns, and so we have 4 pixels per column. So effectively, you know, that's 4 times 4 is 16 bits information for a column. No, I'm doing this wrong again. Yeah, you have 4 pixels, and each pixel has 4 bits, so it's 16 bits, so it's 2 bytes of information. Correct. So, but if you write 2 pixels, then that is exactly 1 byte, right? So you do write in granularity of 2 pixels at a time, because your data is 8 bits. So that's what is happening. So you need to figure that out carefully, how to, you know, how to address effectively, because I think of display as sort of an address mapping, right? How to get to the right coordinates to start writing your characters and so forth. Cool. Alright, so how does the OLED react? Well, if you are writing, say, a particular column 1, row 1, for example, over here, then once that is finished, then the OLED expects you to write the next cell over here. So it's not that you have to tell it to start, you do not have to tell it a different location. It will, by default, it will move to the next cell. And that helps, of course, because then you can go through this whole display and write pixel after a pixel. You can write anything you would like to see. But if you write a character, which may be a little portion out here, yeah, you may want to write a line, and then you need to tell it to jump to this particular position, so that you can do through a command. And then you write the rest, or the next line and the next line. So you'll figure it out. So let's look at initialization. So you will see these types of things in your data sheet. So here we see, so what is this? This is set column start and end address. That's the description of this command. And the command is given by this hexadecimal number. So you write a command to the OLED, which is that hexadecimal number. Now the OLED expects you to be in this mode, meaning that it expects to see a start address and next an end address. So you write data now, which is first your column start and then your column end. And in our case, we have created in here, maybe not in there, okay, whatever, but you would have, okay, well, we have this here. So we have an OLED row, column start and column end and so forth. And that is what you could use when writing uh, when writing this particular thing. So what we will be doing is we will be using this, and then we will give it what we just defined, those constants, to the inputs that we give here. And the inputs here are just named like this so that you understand what we're doing. Right? So we will call set column address with those two defines that we have here. The column start and the column end. We can also give directly the hexadecimal numbers, but if you do it like this, then it makes more sense. Alright, so you will do this also with the set row address and so on. And then you have a whole bunch of other functionalities that you need to do, but they all look like this. So you just have to code it up in short phrases like that. And that's what you gotta do. That will become your library. Again, make sure for the SPI that you take care of this situation, right? When you run SPI with respect to the debug wire and so forth. So you've seen this already a couple of times. So we have the SPI definitions. This is the board schematic of the whole thing together that we talked about. And now I'd like to quickly go over yet another slideshow very quickly. If you have, well, we don't have too much time, but I wanted to already start talking a little bit about the solution itself, just to give you some impression of what's going on here. So yeah, we'll have this write command. You know, we and make sure to assert a command signal, blah blah blah. You have the SRAM mix. So this is task. This is task 1 actually. So you assert the write signal. Remember that sequence for writing. So you need to go through all of this in the proper sequence. And that's what this is. So you need to just translate that data, that picture, that visual that you had, in this way. All right, yeah. What can I say? You just have to struggle with this a little bit, but you will just have to translate it and play with it. But it is very natural. What is written out here is a direct translation of that picture that we just discussed. And then instead of a command, you can also write a data. There's only one spot that should be different somewhere. Oh, here it is. Over here. So you will actually do a command, or sorry, you will do in this case data. Anyway, you will figure it out. So we have the initialization stuff. Well, we need to create all those commands. And there are tons of those. And it keeps on going. And then finally you can do this initialization sequence. Don't forget to turn off your interrupts again, right? When you're doing initialization. Because you just don't want this to be you do not want this to be interrupted. And this is all in the data sheet, and then you turn it on again. So you wrap it again. And then you have what we discussed earlier, the OLED configuration. You have your SPI because you use your SPI stuff. For the task 2, you have to you want to display characters, so you figure out how to code this up at the right spot. Task 3, you display the string, which is easy because you already have this other functionality. Then and you will do it in your own style, of course. And then you have your initializations for, say, in the main program. OLED initialize, the SRAM configure, because you want to use both. And you start to work with both the SRAM and your OLED. And you're going to just write, use the character map to write text to your OLED, which is just, in the end, just something as simple as this, just printing a string, that's it. So that should be straightforward, that part. Yes, it takes a little bit of coding, but that's it.